Okay. Hello, everyone in chat. Hopefully you guys can hear me all right. I haven't fully tested the whole stream setup. If someone in chat could just let me know if there's actually audio coming through. All right, cool. Awesome, cool. So thanks for joining the stream. I'm really excited about sort of my kind of plans for the stream itself and what we're going to be able to build and teach and all that. I've been working on blog posts and video series and Pluralsight courses for a while, and now sort of given the environment we're in, I've been doing a lot more online conferences rather than the in-person ones, which is sort of really, I guess, sparked the interest that I've had for a little bit around doing these live stream builds and stuff. So, I kind of mostly have been building things and doing R&D and all these cool things like by myself and maybe blogging a little bit about it for the last like 2 years, and I figure it's a good time to actually sort of come out and start showing you guys what I've been up to, the types of things I've been learning, and then helping sort of break down those barriers in a really fun way. A lot of dev streams that I watch personally are fun for me to watch, are super educational. They're showing me working on like the frameworks that I use every day, which is exciting to sort of see the dev process behind that stuff. But I kind of want to take a little bit of a different approach than the traditional dev stream and kind of like blend my interests and my ways of building and designing things to really just help break down the different barriers that kind of exist in software development. So my goal is to make sure there's something for everyone. If you're already an expert architect learning about the ways that I build and architect my solutions, and even just using the same solutions you might already use that are the same in different tech, or people who are just interested in gaming, learning how we can really build things that manipulate the games we play all the time, and then even just if you're new to programming, learning how to come in and sort of start from scratch with some of the raw aspects. So some important things I want to outline before we really get started. Ask questions in chat, like literally anything. And if people are asking questions that you think are pedantic or simple, like just don't be shaming anyone in chat, but also feel free to help out and provide answers as well. I'll try to keep an eye on it every now and then to answer some questions as we're building stuff. But also bring some of your own ideas to the table, and we can really make some cool things. So in this first stream, I wanted to kind of start strong and bring some of these ideas I've been toying with to life. So for the last couple of years, I've been working a lot in the conversational AI space, doing a lot with like Alexa and Google Assistant, and I need to mute my devices before they start talking back to me already. Bixby, Cortana, Siri, all that, and mixing that with app development. Now, I've also been playing some video games, given that we're in this sort of quarantine mode and there isn't much else to do all the time. So I figured what would be a really fun project is to actually build something where we can use Alexa to get better at Warzone, which is a game mode in Call of Duty Modern Warfare that I've been playing a bit. So what I want to sort of start doing here is actually put together a project from scratch that we're going to be sort of building, and I'll start by just kind of outlining what the expectation is and what we're going to be working on and what the end result should be. So, my sort of goal, I've got all these different devices behind me. I've got HomePods, Google Home Minis, Echoes. I've even got a Cortana speaker back there. I've got another little Echo down here. It's what I work with, so they're here all the time. And what I want to be able to do is, while I'm also at my sort of media and gaming station here, is be able to basically shout commands at my devices and have them actually affect the in-game content and the in-game actions that I'm taking with my mouse and keyboard. So that requires a couple different things, and my biggest real concern about it is not so much if it's going to be possible to build it. I'm confident we can get this working. I'm mostly worried to see if I get banned from the game because we'll technically be doing some things that are not driven from mouse and keyboard, and I'm wondering if the sort of virtual inputs will be caught by anti-cheat, but I can always try to talk to Activision about that. But anyway, so with that in mind, right, the goal is to just shout commands at my device and have things actually execute in game. So using Alexa, we need to actually have our Alexa take commands. We need to be able to route those commands to business logic so that we actually know, like, if I said this, I need to do that. We need to have that actually hosted somewhere in order for Alexa to talk to it. It's called an Alexa skill. So that Alexa skill needs to then be able to talk to my computer itself So we need to then route commands down to a client app on desktop. And then we need to be able to execute in-game commands or hotkeys from that sort of business logic. So that's sort of the 4 steps that we basically need to take with this end solution. So what I usually like to start with is a nice sort of architecture diagram, and my favorite tool for that is Paint, because I can just draw sort of random things around and basically just actually sort of visualize some of it. So let me see if I can make this a little bigger. You can zoom in a bit here. So first things first, we need to have Alexa actually talk to us. So that's going to be Alexa itself. These run through Alexa skills, which are then hosted somewhere, and we can use proxies and stuff so we can run it all locally. But basically, Alexa is going to be sending information to our skill. And my sort of mouse writing is beautiful. Our skill is then going to do whatever it needs to send stuff to our desktop. So we need our desktop app. We'll just call this app. And then that app is going to basically just behind the scenes basically execute commands in game. So in the end, we have our actual sort of game here. Now there's basically certain types of tech and techniques that we can use in building this. And basically, I'll be teaching you how to do all this cool Alexa stuff while we go through this, teaching you about how we can actually use and host a skill and actually communicate to a desktop app in real time, which is pretty cool. Something that I don't really see very often of like high utility, high functionality in these Alexa skills. And we'll be learning about basically building test tools for executing in-game commands from a different app. But basically, what we're going to do is we're going to build an ASP.NET Core API that's going to have the skill hosted itself. And then we're going to be using SignalR and a UWP app as our client that's going to be talking to that same API. So we don't have to worry about learning AWS stuff. We don't have to worry about like the nuances of other sort of WebSocket technologies. We're going to be focused entirely on C# and .NET Core. And really sort of honing in all of that in one project to just make it sort of work. And then we'll have to see if we actually can get it to work and actually execute some of these commands and see those actions come up in game. So the first thing that I usually do when I'm starting a new project, once I have the sort of idea formed, is actually create a GitHub repository. So I'll create a repository here. We'll be pushing all our code to it, and then we can sort of go from there. So I'm going to start by creating a new repo. Naming things is the hardest. Let me call this like Warzone voice controller. And the description will be that using virtual assistants to execute commands in Warzone. And we'll make it public. I like to personally initialize it with a readme and gitignore. That way I can just pull it down, start my project, and get it going. We'll make it MIT licensed so that anyone can play with this. So I'm going to create it. I'm going to clone it down to my local, and then we're going to start in Visual Studio basically creating that project. So I'm going to probably use mostly UI tools for Git, again, because I don't want to basically like enforce having to learn about like the Git CLI and stuff like that, especially for beginners. There's tools out there to make it easier. So we'll just be using the Git CLI here. This actually is really small. I might end up changing my resolution here. I'm working on a high-res monitor. But anyway, all right, so we've got it cloned. We've got it in our projects folder. So if I head over here, we have our Warzone voice controller. So let's just start by creating a new solution. So I'm going to create a new project. I'm going to actually start with an empty solution, empty project, and where is it? Somewhere in here I can just, there we go, blank solution. Because we're going to be adding like a bunch of different stuff, and I don't like the sort of opinionated templates when doing that. But we can go in here, and we'll call this our Warzone voice controller solution. And then we'll even just go grab that folder we were just in. Projects here. And I'm going to create a new folder just for source for us to put all this stuff in. Cool. So we'll create our solution, then we'll start adding different projects in here. Basically, there's like, I think 3 different projects we really need to start off with. We need the API. We need the UWP app, and then we need some stuff to share between the two. So things like basic models and perhaps business logic or connection info and stuff like that. So I'm going to start there and just scaffold these 3 projects out. And let me change this to light theme so it's a little bit easier to read. There we go. Wait for it to actually take effect. Cool. So I'm going to go ahead and just file new project in here, or actually do it from the right side. Add new project. So I'm going to start off by just adding that models, basically .NET Standard library class that we have. So I need .NET Standard, .NET Standard. Here we go. And we'll name this our Warzone Voice Controller Core Models. Sweet. Now let's go add these other projects too before we kind of get ahead of ourselves. So I'm going to add another new project. We need our API. So I'm going to do an ASP.NET Core web application. So we can create that. We'll call that Warzone Voice Controller. We'll just call it API. And we'll start with the API template, I think. And we'll configure it for HTTPS. I'm not going to bother with Docker or containers or anything like that. We're probably just going to run it all locally. That way I don't have to pay for hosting this stuff, and we'll just use like a reverse proxy in front of it. Cool, so now we have our API project, and now the last one, like I said, is that UWP project to actually host the client side on my desktop. So let's go ahead and create a new project here, and I have a blank universal Windows app. We'll call this Warzone Voice Controller.client. And I'll use the default settings there. Sweet. So let's start first by basically talking about how the skill is going to work. So thinking about those logical steps of like, I need to say something to my Alexa device, it needs to execute something in my skill, and then we need to send it back down. So the way I like to think about that in building it is basically like, let's scaffold the actual skill itself. That way we can start connecting it to our API right away. Thanks for the follow, Mizu. So what I'm going to do here is create a controller in our API project. So the cool thing about Alexa development, and this is really mostly true for all of the different virtual assistants when you're building stuff, is that you can host it basically anywhere you want. Like in the end, like it's all about defining your language model, which we can simplify pretty easily, especially in this scenario. So you build your language model, you define your endpoint. So in the case of Alexa, that can be a Lambda on AWS, which is super simple. You don't really have to worry much about hosting costs or anything like that. Or it can be an API. It just has to be over HTTPS and public facing and be able to consume the same JSON. Thanks. So what we're going to be doing with that is basically starting with just the API endpoints. We're not going to worry about the Lambda nuances, having to worry about AWS hosting or anything like that. So all we need to do is then scaffold our language model, set the endpoint, which again we'll just point to our code that we're going to execute. And as long as it takes the right JSON structure in that Alexa skills kit is going to send to us, and we send the right stuff back to basically tell it what to say or what to show, all that good stuff, then we're off and running. So what I'm going to do now is head over into the Alexa developer console, and we'll start scaffolding the skill as well. So to start building things for Alexa, like I said before, they're called skills, and there's a bunch of different types of skills. You can see a list of like a few I have here that are mostly just demo stuff or from PubConf and things like that. But you have to create an Amazon developer account. So that does require you to actually like either register a business or register yourself. You can't just like sign in with your normal Amazon account. You basically have to like link it into a developer account. But I already have that, so we'll sort of skip that phase. But we can start by creating a new skill. Like I said, there's a bunch of different types of skills, and they function in a different way, and they're built in a different way, depending on which one of these you basically want to use. But the first thing you have to do is give it a name. So I'm going to call this our Warzone controller. We're going to use default English US because I speak English and I live in the US. And now let me sort of just break down these different skill types. So there's custom, which is the one we're going to end up using. It's more conversational. You get to define your own language model, choose what happens, execute your own code in the way you want. It's exactly what we want in this scenario. There's also flash briefings, which are really cool. Basically, you can register a flash briefing skill for your morning routine and stuff like that if you're an Alexa user. And that means that it's basically providing like updated news and things like that. So if I were, for example, working for NPR, I could create a flash briefing where people would then listen to the latest news from NPR. And you can play audio or you can do output speech from Alexa. Smart home is sort of obvious in its name and in this example here where it basically works with device registration. So you register a device type. And when you have that device type registered, you can do things like turn it on, turn it off, change certain settings depending on the type of device it is. There's also music skills, which are like the Spotify's, Apple Music's, Deezer's of the world, where it handles all of the language and scaffolding around it as long as you can provide the stream for it. Video is pretty similar. So if I were Netflix, I'd be building a video skill. People can browse my video catalog and actually stream the video if you have a screen-based device like an Echo Show, a Fire TV, something like that. There's meetings, which are basically for internal like business use. You can book a room, schedule meetings, stuff like that. And then education. These two are pretty new. And then you basically then choose how you want to host it. So you can either just host it right on Alexa and use Node or Python, which means you can actually just write the code in the browser, which is pretty cool. But that's not what we're after. I'm a .NET dev. For the most part, I use C# as like my daily driver language. So we'll be focused on that. And that way we can also share more code between our client app, that Windows app that will be also written in C#. So like I said, we're just going to actually choose these default selections here of custom and provisioning our own because we're going to end up running this as an API. We're going to probably run it locally, run a reverse proxy over it. That way we can just get like a public URL from ngrok or something like that and start hitting it against our local machine without having to even host anything. So I'm going to go ahead and click Create Skill. And so this is going to take me into the build section where I can basically choose to start from scratch. Again, this is what we're going to do. Or I can basically kind of start with like these pre-built things where it's like building a quiz game, a fact skill, or in this case a high-low game. These are really mostly there to kind of get you started. If you don't know how to build language models, if you don't understand how Alexa skills work in general, and especially their language model. But I'm going to be teaching you all that as we go through anyway, so we're going to choose to start from scratch. So the first thing you see when we get dropped in here is our actual console for just this skill. So now we have our Warzone controller. It is a skill. It's going to be in that listing you saw before. And now we're at this point where we can edit our language model. Alexa calls it the interaction model, and it basically includes a few different things here. We have to choose an invocation, which is the name we give it that the people are going to actually say to open it. So that's like, we can just call this Warzone controller, which is default, but you can always make it different than your display name, and that's fine. Then we worry about what are called intents. An intent is basically a category of what someone is trying to do when they're speaking to the device. So you can see there's some built-in intents here from Amazon, the fallback intent, cancel, help, stop, and navigate home. So as an example, in the help intent, we're defining what people are going to say that's going to go through this help intent. So what is someone going to say if they need help? So I can enter things like help, or I need help, or help me, stuff like that. And then we can save that, and then we build the model, and that's just going to run stuff behind the scenes before we can use it. So we're going to be focused mostly on building our own intents. And there's a few different ones we can do here. There's basically the different commands that we need to actually execute in game. We're going to make a different intent for each one of them, for the most part anyway. So when we're building these intents, we should focus mostly on separating them around the way people are going to say it. Because when we get that data from when someone said or hit a certain intent sent over to our API, we don't actually get a whole lot. Like, we don't get the original text of what someone said. We don't get the audio of what they said. So we can't do all this like crazy custom processing. Instead, we get the name of the intent and what are called slot values that are within it, which I don't think we'll even necessarily need in this scenario. But let's start by creating one. So for those of you who haven't played Warzone, it's like I said in the beginning of the stream, it's a a game mode within Call of Duty's Modern Warfare. And that's a first-person shooter game where you're in the first-person perspective of your character, you're running around, you're picking up weapons and guns, and then you're fighting your way to be the last one standing out of about 150 people. So there's things that we can do along that while we're actually playing in that game mode that we should create these intents for. So as an example, I'm going to create one for reloading. So when I need to reload my gun, if I've run out of ammo or I'm close to running out, I can force a reload. When I'm playing the game, that's all I have to do is click the R key. If you're on mouse and keyboard anyway, I honestly don't know what it is on the controllers because I don't play with those. But on mouse and keyboard, if you press R, you reload. So we basically want to create a command to do that instead of having to hit the keyboard. That way I can just focus on my movement and mouse control and just shout that I need to reload, and it'll reload for me. That's our goal. So we're gonna call this the reload intent. Naming convention is typically to name an intent with what's called Pascal casing, which is a capital at the start of each word with no spaces in between. You can kind of see that in the ones that Amazon had made. Hey, thanks, Benny, for the follow. So like fallback intent here, the F is capital, the I is capital. So that's what we're going to go with reload intent. So we create it, and just like I was showing you in the help intent, we enter some ways that someone might actually want to trigger this intent. So we can go ahead and just say reload. That makes sense. If I just say, Alexa, tell Warzone controller to reload, that's what I want to happen. We can make it more polite. We can say please reload or reload please. Or more likely, me playing the game, I'm going to just shout it a whole bunch of times, reload, 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 as I'm panicking and getting shot at by the bad guys. We don't need slots or any of these delegation strategies below, but I'll explain it real quick just in case we don't ever get to it in this app or skill. But essentially, what slots are, it's a piece of data that you can get out of the intent that you might actually need to use when choosing what to do based off of the intent. So for example, in a previous skill, in an example I put together for a demo on stage, we had like the animal fact intent. It would be me saying like, tell me a dog fact or tell me a fact about cheetahs, right? So in order to get the fact, we need to know what animal the person was asking about. So we create a slot for that, and we use those slots in patterns in the phrase. So for example, here, if I wanted to like choose a gun type that I wanted to reload, I could create a new slot called gun type, and then we can choose the slot type. And there are basically pre-built ones from Amazon, and there are also ways to build your own custom ones where you just enter like the different values that it could be. But for example, if I wanted to choose the animal one, if it was an animal, then I can now use it up here and say reload, and then use these sort of curly braces to separate it, reload gun type. So now if I said like reload dog, we would know that the gun type was dog in this scenario. Kind of a bad example, so I kind of mix two things, but that's the idea, is we can actually start to pull out those values, especially because Amazon doesn't send all of that original text. So we need to know just the intent and the slots, and that's all we get to work with. But I'll delete these just because we don't actually need them for this. So reload, reload, reload please, please reload. Those all sound good to me. So now we can save it and build it again, and we can add a few more intents. But before we do that, we need to actually now start to handle all of these requests on our side and then set up the endpoint for it. So like I was saying before, endpoints are where we actually tell Alexa where to send all this data to when we're building it. So this is where we're going to want to point it to our API once we're done building it. And so that's where you can choose whether you want to use a Lambda if you're using AWS, and you can just put in your Lambda's ID, or you can do it over HTTPS and you need to put in the URL. So that's what we'll be doing in a little bit. So before we start adding more intents and everything else, let's actually start to get this stuff wired up and start to test it out. So to do that, we're going to go and build out our API a bit. What I'm going to do first is go into this controller section, and I'm going to add a new controller here. I can leave it as empty for API, and then we're going to call this our Alexa controller. So this is going to be where we put all the endpoints that we actually need Amazon to send the request to. And we got to wait for it to scaffold some stuff. Not sure why it needs entity framework. I might need to clean this up a bit. My goodness, this is taking a while. I should have just done it as a class. Generating code. Not sure what's taking that. Yeah, it took that long just to generate like 5 lines of code. Super cool. All right, I'm gonna also just delete all this stuff that was in here before. These are like the samples that come when you spin up a new empty .NET API. Let me also zoom this in quite a bit so you can actually read it. So I'll just delete this stuff. We don't need the weather forecast controller. We don't need the weather forecast object. We really only right now at least care about this Alexa controller. Now, like I said, Amazon sends a specific structure of data to us, and we need to be able to handle that JSON structure in our actual request, and then send the same expected structure back down. So there's what's called a skill request and a skill response, and those are the structures we need to work with. Now, Amazon doesn't have an official set of tools for C#. They have some samples out there where they basically like only create the classes and models and stuff like that for what they need. But luckily, Tim Hewer and Stephen Pears have both worked on quite a lot of tools for .NET developers like us to use in C# without having to worry about the nuances of the models and all the complexities behind the stuff they send. So what I'm going to do is add a Nougat package here, and we're going to add the Alexa.NET Nougat package. So I can search for it. Not installed, obviously. There's nothing installed. And this is the one I want. Like I said, Tim Hewer and Stephen Pears, shout out to them. They've done an amazing job. Both of them and some other people in the community have also done a lot of like extension stuff. So if you're working with gadgets, for example, like the buttons that I have over here, like if you're using these buttons for anything, these are Amazon Alexa buttons, then you need to use the gadgets controller to actually use that, or like the sound library or the handler pattern from the request handler, stuff like that. But we only really need the base one, so I can go ahead and install this, which will give me the library and tools that I need to actually start using and executing against. And the only place we really need this is in the API. Our models don't necessarily care about it, and our controller client that's going to run on our desktop definitely shouldn't know about it, because that's going to restrict us to using Alexa rather than being able to plug in other virtual assistants. I'd love to, in a follow-up stream at some point, also use Google Assistant or Cortana or Siri or something like that to also use that same controller that we're going to make. So for now, we'll focus just on importing it into our API, and it looks like it finished installing. We got a little green check mark here. So now we can actually build our endpoint. So every request that's sent from Alexa is over HTTP post, which means we need to create a post endpoint that's going to handle it. So I'm going to create a new method here that's going to be where that entry point goes into, and we'll call this HTTP post, and I'll have a route here that's just called handle request. So this, I think we can probably just put all the code in here for now until we start to actually scaffold, like sending the WebSockets and stuff down so we can start to test. So I'm going to call this a public Alexa or skill response, because that's the data structure we need to send back down, which means I can now pull in that alexa.net.response one, and we'll call this handle request. And this needs to take in from the body and a skill request, which will pull in another namespace, and we'll call this request, or even better, skill request. So the skill response, basically, if we can kind of dig into these, let me start with the request, right? So we can take a look at what we actually get sent to us. So the base skill request sends us the version, which is just like a 1.0 string. We get session information, which means we can know if it's a unique session ID, if it's a new session, what attributes are sent along there. So if we want to save some information about the user as we go, details about the user itself and the application, all that good stuff, which we can use in more complex scenarios, or even just to validate that it's coming from one of my devices and one of you guys aren't trying to hit my local socket. We then have the context, which has like the person's location if you have permission to use that, audio player state, and Alexa system stuff. And then there's other inner types of this request. So this request object is the thing we're going to be focused on the most. And there's different types of requests. You'll see this is an abstract class, meaning that this is only going to contain the abstract information we need or the shared information. There are other types of requests that inherit from this one. For example, the intent request, which is how we can actually pull the data out about the intent that was hit, or the launch request, which is when someone actually opens the skill. We need to be able to handle those. Now, when we build our response, we're going to be sending back this skill response which again takes a version. We can send those session attributes like I was talking about, and then we have the response body, which can contain output speech. So what do I want Alexa to say? It can contain a card. Should we show something? The cards can also show up in the mobile app. We can provide a reprompt, which means if the person didn't reply within like 7 or 8 seconds, we can basically ask them again what they wanted to say, and then we can say if it should end the session or not. So this means that if this is set to false, like we should not end the session, then people can keep asking questions again or saying more commands and stuff. If it does end the session, then the microphone closes, Alexa stops listening, you're now out of that skill. To get back in, you got to reopen it. And then there are directives, which is a whole wonderful world of doing many things, including showing videos, using custom display with Alexa presentation language, starting the audio player, and controlling devices, starting Amazon Pay. Like everything else basically runs through the directives. So let's start for now in the Alexa controller by just returning a simple skill response. Part of the Alexa.net library is also this response builder library or tool, I believe anyway. So I can say response builder dot say or tell. Yep. So now I can provide output speech either in SSML, or I can just provide a basic string here. So let's just say like hello world, right? That's what we want to provide when someone opens something. And we can just return this straight away. So that's it. All our build errors are gone. We have everything we need to hit this response. So if we now run this by setting it as our startup project, yes, I definitely trust my own SSL certificate. It's going to default us to the weather forecast, but that's fine. There's nothing that's going to be there. So we have our localhost and our port number. Now, what I need to do is create a proxy in front of this, because localhost just means that it's running on my machine. So I can talk to this from other things running on my machine, but I can't have Alexa in its cloud environment actually send a request to my localhost. It needs an actual URL, a .com, a .net, or something like that. So what we use instead is what's called a proxy, or even sometimes a reverse proxy in tandem with that. So what we can do is use a couple of different tools to provide that proxy. Let me pull up a few here as an example. So there's a tool called ngrok, and then there's another one that I use, which I'll probably use, which is called the Bespoken proxy. So basically what you do is you install ngrok, which acts as a proxy. You then run the ngrok command from your command line and tell it what port it should be the proxy in front of. And then it gives you a URL. Ngrok, unless you're paying for it, will give you a new URL each time, which I don't have my pro version set up on this machine. But what I can use is the Bespoken proxy. So they're another tool in this sort of voice space that does a lot of stuff around testing. But they also provide this super simple tool for doing these proxies. So again, it's just a command line to call proxy HTTP in that port. So instead of 999, we're going to be using that 4000 whatever 44379. So I'm going to pull up a PowerShell window here, and I already have Bespoken set up. So now I can just call this proxy with this. So I can say BST proxy HTTP and my port. So now you'll see it scaffold everything. Now we get this actual URL, right? So this is our HTTPS URL, commonshelly.bespoken.link. And this is what we can actually provide to Alexa to hit, because it is a public-facing URL. If I take this and go in the browser with it, it's going to now actually send requests to my API. So what we should be able to do is take this, and I'll stop this tab, go back to our Alexa developer console, and go to this endpoint section where we set it up. So I'm going to paste my URL here, and I'm going to choose my SSL certificate type to say that it's one using a subdomain with a wildcard, because it's used for this common Shelly one. Now I can't just put just this URL, I need to grab the route from my controller. So we have that URL /API /Alexa /handle request. So let's go type that in as well. API, Alexa, handle request. And then we can save it. Now we can go over and test by going to the test tab and turning on test mode. when you turn on testing for a skill in the Alexa developer console, you can start to use the simulator, which is where you can type things in or you can use the microphone to speak to it. But it also means if you have any Alexa devices that are using the same account that you're signed in as, so this is my personal account I'm signed in as, and I have all of these devices over here all set up with my personal stuff too, we can actually test on those. But we can start to test by saying open Warzone controller, because that's our invocation name. Now if we go here, we can see that we actually got the request sent to us. So this is that proxy window I was showing you. Let me zoom in a bit. And we can see all the data that was sent. So we got this version, like I said, we had that session object, context, the viewport telling us about the device we have, and then the request object itself. This is a session N1 because we had an error. This probably means that our proxy is not actually working connecting to our ASP.NET Core app, but we can also see the original launch request that happened, which threw an error. So we can see, it, just looking at the logs here, that Bespoken was trying to proxy to our API at that port, but something is getting blocked. Now what we can do to work around that is to check in on our app config or host config. So if I go in here and go to source, hey James Nini, thanks for the follow. I'm going to go edit our application host config file. So if I open this in VS Code, there's some stuff in here that basically controls the proxy and doesn't allow it to work. So what I need to do is find what that is. It's somewhere in here with origins. Let's see if I can find an origin. I might end up needing to look this up. There's a whole bunch of stuff in here. Where's that host? Here we go. This feels like the right spot. Yeah, binding information. Cool. So I need to update some stuff here to make the binding work with proxies, and I can never remember how to do it, so we're going to look it up. ASP.NET Core proxy settings ngrok is an example. This is what I wanted. You can see it's already purple because I go to this blog all the time. Thanks, Jerry Pelser, if I'm saying that right. You've helped me all too many times. Cool. So he's talking about the ngrok stuff, getting that bad gateway, which is exactly what we're getting. This is doing header rerouting, and that's basically what I need to tell it to do in the other side. Let's see. There's an application host.config binding. Yeah. Okay, so we might need to do some of this stuff then. See if we can't grab this. Okay, so what I'm going to do is stop running this. We'll keep the proxy running, but I'm going to go into the startup, which is exactly where they dropped that. So let's see. Probably just need to pull in a namespace. Cool. Alright, I'm going to try to run this again and see if we can't get the proxy to work. Awesome, so we're running, and now we can go back to the Alexa developer console, copy this, and try again. Looks like it's actually thinking this time. Let's see if we can't get something to hit here. Nope. Connection reset. Let's figure this out. I don't need that. I need to figure out config. I knew there was something I had to do in the application host config. I have another example of where I've done it too. One second, let me pull this over here. Just gotta find out where my working app config is for doing the proxies. There we go, let's try this one. Binding. Alright, let's see if we can't grab this stuff. I want this one. Oh, I'm trying to port to the HTTPS one. I want this. I think I want this one. All right, let's restart our proxy and use the other port here. What is it? 49505. All right. Is this still running? This is still running. We're gonna go try this again. Come on, give me a welcome message. Still not hitting it. Binary data. Oh, we did send something back. That's good. It means it tried to do something. I'm going to back this out and restart it. Is this HTTPS? Okay. We're getting the post. Why aren't we getting the proxy? Worst case, I can always just go host this somewhere and we can hit it. But I was hoping to get the proxy to work. Let's just try a couple more things here. ngrok proxy ASP.NET Core 504 502. Try it with BST. Welcome to Debugging with Alex, where we read other people's blog posts on how they actually fix proxy issues. That's not what I wanted. It's also 502. Alright, that's fine. We're going to publish it then. So let's do this. I'm going to do the bad thing of right-click publishing this to a new Azure environment. So we're going to create a new Azure app service, and we'll create our profile. Got to choose what account to make it under. I'm going to create a new resource group called Suave Streams, where we'll put all of this test stuff going forward, and we're going to choose a new plan, and it's going to be free because I'm not paying money for it, and that's fine, and we'll do no insights, and we'll call this our Warzone voice controller, and hopefully no one's taking that, which would be cool. Alright, cool. So we're going to create that in the background. We can let that run. While that's going on, essentially what's happening is I'm just pushing this to Azure, where we're going to get an actual HTTPS URL for us that we can use instead of trying to run it through the proxy. That does mean, though, that whenever we want to actually push updates from our code, we need to republish it each time, but that's fine for now. So in the meantime, let's head back over to the Alexa developer console and add some more of the intents for the different types of actions we need to perform. So we have our reload intent. We're going to be basically doing the same thing for certain other actions. So some other things you can do in Warzone is put in armor if you're low on armor. So let's go create that one. Call this the armor intent. And again, we'll create it. I'll just say armor, put on armor, insert armor, all the different ways we might want to say it. And again, we can save that. Let's go add another one now. Let's see, we can reload, we can put in armor, we should be able to sprint, which is holding shift. So we'll say sprint intent. So we'll say sprint, run, go fast, and we'll add that one. Now let's go add some more. If I want to shoot, we'll call it the shoot intent. We'll say shoot, fire, attack, stuff like that, and we'll save that. Anyone else here who plays Warzone, think of other actions they'd want to be able to shout at their Alexa in order to actually have it perform it. These are probably the ones that I think are going to be most... Oh, we should do the ping one. So in Warzone, you can also ping certain things by using, I think the default is Alt key. Oh, cut shoot is another good idea. Cool. And we can also do like jump and stuff too, or crouch. Those are other good ones. Okay, so we want to ping and ping that maybe. So that will actually like show up for people on your team to say that you've marked something. And there's also another type of ping called an enemy ping, which requires you to hit Alt or whatever your key is twice. So we'll say enemy or enemy ping just to provide some variation here. So now let's do cut shoot. So we'll do cut shoot intent. Say cut shoot. Cut parachute. So this is when you're starting in the game, or really at all if you jump off a high building, you have an infinite number of parachutes on your back in Warzone. But basically the best strategy for getting really far is to continuously pop a parachute and then cut it, and you kind of keep forward momentum. So we'll save that. And then we'll do another one for jump intent. We'll say jump. We can also use this for the same one as open parachute, because it's the same key for the most part, or at least in my key binding. So we'll also just call it parachute. And we'll save it. And we should do crouch too. Crouch intent. Call it crouch. Squat. It's another funny one. And again, we can save that. And then we might also want to have one for going prone, which is to lay down in game, which is for the most part used in drop shots and stuff like that, but we'll use it in some other scenarios too. We can call it prone, we can say hide, lay down, some of that stuff. Cool. Now let's check in on our deployment. All right, cool. So we got this URL. I'm going to copy this. It's kind of hard to see. It's probably pretty small, but basically Warzone voicecontroller.azurewebsites.net is going to be our URL. So we can actually go back over here and now head into our Endpoint tab, and we'll swap out the proxy link for that one. So we'll save that. Now let's see if we can hit this one at least and try to get it to work. So again, we'll say open Warzone controller. Please give us the hello world. No! Okay, we can look at the device logs, see what came back, or maybe it's just not actually set up yet. Oh, wait, did it not finish deploying? It didn't release my code. Try deploying it again. Maybe we just created it, but we haven't actually deployed our code yet. So let's try doing that. We can, again, just right-click publish, which is probably what we're going to be doing all the time. In my past life, when I used to have to do this a lot when doing like Sitecore web development, which is like all just about the crappy way of publishing, I used to just have a keyboard shortcut of just like Control-P publish and overrode the like print command. That way I can just do it all the time. But in this case, it's fine. We can always keep this tab open too and publish it. So let's make sure this goes all the way through and that we do get it on the sort of side behind it. But once we do, and we can prove that we get that hello world response that we have in our controller, then we can really start to play around with going through the intents, making sure we're performing the right logic on the right intents, and then we'll set up our SignalR WebSockets. All right, so we've successfully restarted. We now don't have that default screen here like this one. Like if I refresh this, we should get nothing. It should be 404 because we don't have anything set up at root. So now let's go back over here and try again. Come on, help me out here. Let's see, what did we mess up now? Did we get the wrong endpoint? Let's do this. We can go to the device log if we scroll down. Close this. I'm also going to want to take a look at the response we sent back, so I can go to view 2 of 2. An exception occurred while dispatching the request to the skill. See if we get anything worthwhile in here. Doesn't really look like it. Turn to 500. Maybe we're just messing something up here. So let's do this. I'm gonna add Swagger to this web project. That way we can debug it locally by actually sending the raw request data up. So what I'm gonna do is go back to Nougat, and we're gonna look up the swashbuckler. Should find it. No? Swagger? There we go. We want the swashbuckle, not buckler, full Swagger one, which for those of you who haven't used this before, it's really, really cool. What it does is it actually generates a little bit of a front end in front of your API, so that way you can actually just test it, including making HTTP post calls and stuff like that without having to like go to Postman. We can of course go to Postman once we start running it, but I find this a little bit easier. So all we need to do now is go to startup, but I'm actually just going to look up the docs for swashbuckle ASP.NET Core. That way we can pull up the right docs here and make sure we use the right startup stuff. So basically stuff we have to call in the startup right after MVC. So you see how we have this add MVC in their docs there. Right after that we need to put this code. If we go to our startup class, this is where we need to actually add it underneath this add controller. So we're going to add Swagger gen, bring in the namespace we're missing, which I think they documented here. We want this one. Where is this coming from? Using swashbuckle, ASP.NET Core, Swagger. Am I like missing something here? Did I probably installed the wrong package. Swashbuckle. Oh yeah, this is the one that actually adds all of them. Duh. Alright, we're gonna do this one instead, and then we should get that extension method. Cool. There we go. Now it came in. Awesome. So there's a couple other things we need to do first too. We want this use Swagger, and we want the use Swagger UI, and we're going to call those in the configure section. I want to make sure I get the order right, because the order does actually matter at that bottom section, but I think it's like the last thing we need to call down here, so let's just try that. And then there's the other one right under it, which is what's going to actually give us the UI. So now when we run our API, what I want to do is not default to going to /weather forecast. I want it to go to /swagger, because that's going to be our default here. So let's run that now. And when we run this locally, we go to /swagger. We should see the endpoint load up for us. Here we go. So now this is all just running against our local, and we can start to test it out. So for example, to test this way, what I can do is go to the Alexa developer console and take this whole JSON object, because this is what Alexa is sending to our endpoint. So I can just copy this and then go over to this side of things and paste it. Now when we execute it, we can start to see what's going on. Deserialization of reference types without parameters. Parameterless constructor is not supported. Okay, so there's something just not able to actually process the skill requests. So let's go to the github.com/Tim Hewer/ I know it's in here somewhere. No. To Alexa.net. This is the one. So this is the GitHub source for the library we're using. I just want to make sure that we're actually like using the right stuff here. For some reason it doesn't like it. Handling a launch request. I know how to do all this stuff. What I want is why this error is happening. Deserialization of reference types without parameterless constructor is not supported. I'm just going to grab this and search it. See if anyone else has run into this. Base request on. These are all a little bit old. Work when the skill is actually named request, hence calling it rec. Interesting. Trying to see if anyone else has figured out like a better example for handling it. What we could do is basically take it in from the request header instead of taking it in from the request object and using a default, kind of like what this guy's doing, where he's actually like taking the raw HTTP content and reading it. Let's see if we can't. Hold on. Yeah, I'm gonna try to do this. So we do need to make it async. Cool. So let's try to work around this issue where it doesn't like that we're just basically using the skill request. What we can do here is I want to take request dot, just get rid of the await for now, dot body. I think we can read async. It's gonna go into a buffer. I don't really want to do that. Here, let me I have another example of this in my own GitHub. Let me just see what's going on there. Is it this one? Nope. This feels like the right one. Controllers, assistant controller. Yeah, see, this is exactly what we did. Does it not like that we call it request? No, I don't need that. Make sure there's nothing I'm missing in startup to set up the JSON configs. See, this is all like the same stuff. I'm wondering if there's some weird settings in this default project around the JSON deserialization. But like normally what happens is that the Alexa.net SDK has tools for handling the JSON deserialization. So like let's see here. You go back. No, we want this. Alexa.net. There's tools in here for deserializing it property. Like if I go to Alexa.net, they have these like JSON resolvers. Trying to find out where it is. That basically say like, oh, because it's an abstract class, like, but we know it's an intent request, we should be using the intent request sort of thing. I'm just wondering like where that is. Might just be in a different place, or it might just be that's only using JSON.net and I'm not actually using JSON.net. ASP.NET Core 3.1 use Newtonsoft. That's what I want. All right, let's start with this. I think the issue is that that other example I have is using .NET Core 2.1, which defaulted to using Newtonsoft. But ever since .NET Core 3.0, they started basically building in all the JSON handlers. Also because they got James Newton King hired there to run that side of things rather than having to do it as an external package. But the and let's try that again. This is what I want. It's not compatible with 3.0. Oh, 3.1. Am I not in 3.1? Did it really not create as the default 3.1? Here, let's see if we can change this real quick. Yeah, come on. Give me that. And I don't even need those. Alright, we'll save that. It'll reload it. And then we can re-grab the Nougat packages. Load failed. Maybe I should undo what I just did. Uh-oh. I'm gonna put myself in a bad state here. Let me fix this. Just swinging this over here. I can open up that CS project in Visual Studio Code and basically undo what I just did. We should have done it over the API, or over the UI, I mean. Alright, now that's saved. Now let's try to reload. Come on. What else did I mess up here? Group. Yeah, this is fine. We could always just blow this away and restart if it wants to keep being a pain. Project file cannot be loaded. Item group start tag on line 7 does not have a matching end tag of package reference. Oh, whoops. Yeah, that's why. I'm just not smart. That's all. Let's try again with 3.1. See if we can't reload it. All right, cool. All right, now let's go try to fix these Nougat packages up. We should have some updates available to get some of this stuff to 3.1. Just make sure we can build. Current SDK. Oh, I don't even have 3.1 installed. Is that what the issue is? All right, we'll back this out to 3.0. That's fine. We'll just install the other version of the JSON.NET package. All right. Anyway, let's go back to here. We want to re-grab this. We just have to grab the one that's the 3.0 version because we're not running 3.1. So we can grab the latest 3.0.3. Install that, and hopefully that works. Yes, I accept all your licenses, whatever they might be. Okay. Now, what the docs were saying there is when we add MVC, which we need to do up here, services.add MVC, then we need to add Newtonsoft JSON. Cool. So let's try this again. We're going to run it one more time and hope that everything works. I'm also going to take this URL and just run it in a browser tab that's not going to close. That way it doesn't get blown away. Cool. So let's go to try it out again. I'm going to again copy all this JSON and paste it. And all right, we actually hit our breakpoint. So now if we hover over skill requests, we have all that good stuff, which means we can just let this run. And there we go. We have our hello world response. That actually makes me think, like, was the proxy not working simply because it was crashing because I was bad? I'm gonna restart this and see if we can't hit the proxy instead of having to host it. So I'm gonna do this again, rerun the proxy. I'm gonna re-grab this URL, and let's just go back over here to the endpoint, see if we can't hit the proxy, because it'll be a lot easier for us, I think, like not having to do the publishing over and over again. It's kind of a pain. So I'm gonna get rid of that. We'll stick with this one, make sure there's no leading space or trailing space. All right, now let's save this again. Gonna go back over to test. Now let's see if we can open Warzone controller. No, okay. Let's see if we can hit our breakpoint. I have a feeling that it was just two different issues there. Yeah, we're not actually hitting our endpoint. That's fine. All right, so let's go publish this now and make sure we can actually get the response from Alexa. I don't care about that. I'm going to stop debugging. And we'll publish this again. We'll just keep this window up and pinned. All right, publish succeeded. We get our new URL. I'm going to go replace this again for like the 5th time in our endpoint. And get rid of the extra slash. Save. Go back to test. Now let's see if we can open Warzone controller. Now please give me hello world. Oh, we did it. We actually have an Alexa skill. You would think it's my first time doing this. Okay. So we can work with this. We just need to, whenever we're making updates, actually push those changes. Now, what we need to do in our controller is obviously not just send hello world. That's not doing anything. Let's validate that we are actually getting the intents that we want, and we can basically send that back as like the name. So what we can do is in our controller now, we'll keep this at the end, but we're going to want to basically separate to say like if it's launch request, launch, almost said lunch request, then say hello and tell the user the commands. If it's an intent request, then choose what command based on the name of the intent. So within each, basically these little blocks of these comments, let's actually write this code out. So what I can do is say if skill request dot request type, get request type equals type of launch request. We'll grab that namespace. Then we're gonna use this same like tell here. We're gonna say like we're gonna say ask actually. Ask. We'll say welcome to the Warzone controller. Issue a command like jump or cut shoot. And then this has another parameter here for reprompt. We can just pass null. Okay, so now if someone says open Warzone controller, that's going to be a launch request, so we can get to this one. Now, if it's the request type is the type of intent request, I'm going to just move this comment up here. Then we need to basically get the request itself. So we can cast it. So we can say var intent request equals skill request dot request as intent request. So now this is going to give us all sorts of properties about the intent. So let me go dig into this. It inherits from that request one, which is the abstract, which has like some of the basic info that all of the different request types get. But then we get this intent information, which has the name of the intent. This is what we're going to be mostly using. But it also can give you like the slot values and confirmation status and stuff like that. But really, I think we only need the name because we need to say like, okay, if it's the jump intent that we got, then go do a jump. If it's the cut shoot intent, then call the cut shoot. So let's go back to this controller now, and we can just do this starting off with a switch on the intent request dot, no, come on, intent request dot intent dot name. Okay, so let's do if it's I kind of need to like side by side this with this thing here. Let's look at our different names. Actually, just collapse these. We don't need these. All right, we've got reload intent, and these are case sensitive. So we'll say reload intent. Then we can return response builder dot tell you are reloading. And then we're just gonna like copy and paste these for each of these other ones. So now we have reload, armor, sprint, shoot, ping, enemy ping, cut, shoot, jump, crouch, prone. So now let's go and replace all these. Armor intent. We need the sprint intent. We need the shoot intent. Ping, enemy, ping, which I'm realizing now I need to rename because I forgot to put the intent at the end, but we'll do that. Cut, shoot, jump, crouch, and prone. So let's go fix that enemy ping. It should be enemy ping intent just to have the consistent naming convention. So we can just simply do that, save and build again. So now let's change the responses to say you are putting on armor. Putting on armor. You are sprinting. You are shooting. You are pinging. You are pinging bad guys. And you are cutting your shoot. You are jumping. You are crouching. You are prone. So the key difference here with this ask versus tell, you'll notice when we get the launch request, we use ask instead of tell. Ask is going to keep that session open. If you don't keep it open, like I was saying before, it will end the session and cut off the mic, and now to get back in, you have to reopen the skill or do a one-shot. If you use ask, then it keeps going and you can keep reprompting. So realistically, we could change each of these tells to ask to keep it open, but it does mean after we say it, it's going to keep listening, and it will only really work if we need to like say stuff back and forth all the time. But let's do this. At the very end, before we publish again, we're going to just do a tell to say, like, you know, it wasn't one of these things that we understand. So instead we can say, you said something I don't know what to do with. Bye. Awesome. Now let's just publish this again, and then we'll go back into the test console, the developer test console on Alexa, and try some of these other things out. So we'll just keep closing these. Let's go here and go to test. Oh man. And now we'll open Warzone controller again. So now we get that updated message, and we can, let me actually unmute this too so you can hear it. Now we can say things like jump.
You are jumping.
There you go, now we know we're jumping. And it ends the session again. So if I say jump again, it's not going to know what to do.
Play the song Jump, right?
No, do not play the song Jump. Okay, what we can also do is what's called a one-shot invocation or a one-shot intent, which basically means that we can skip this, open, and then say jump by saying one long command. So let's see if we can get that to work. So you can use things like tell Warzone controller to jump.
You are jumping.
And we can basically shortcut it that way. So now I can make short commands out of these. Let's say to crouch. And
you are crouching.
To reload.
You are reloading.
Awesome. So now we have our stuff up and running. We're handling the requests coming in. We have it all separated so we can do different stuff. What we need to do now is actually set up that connection between a client and the our actual API itself, right? So when we actually say crouch, we need to go send information to the app that's running on my desktop, and that app then needs to actually perform the crouch command as an example. So this is just like a general technique that we'll be able to use in like real-world apps as well. Using Alexa to control your desktop applications or web apps or anything else on your computer is extremely powerful. But I just think it's hilarious to see if I can actually get better at Warzone by using her. So let's start by switching gears over to our UWP app to get that set up, and then we'll also add SignalR here to our client. So I'm going to switch this as our startup project. So this is what's called a UWP app, which is Universal Windows Project, Universal Windows Platform. But essentially we have pages that we go to, right? And then in each one of those pages we can do things like add buttons that actually do stuff and connect and things like that. And then we're going to want to take this app and also execute the use of keys behind the scenes. So we basically need to fake me hitting space if I say jump, or fake me hitting 4 if I want to put on armor. But we can start to test that stuff out now with doing the fake key commands, and then we'll glue it all together with the connection between the API and the client to do that stuff. So to start, I have this sort of split view here where we can either drag and drop controls from the toolbox or we can type stuff in. But for example, let's do one here where if we hit if we click a button or something, it will alt tab. Like let's try to set something up like that. So I'm gonna say I'm gonna add a button, and I'm gonna add a click command, and I'm not going to use any other like special frameworks or design patterns or anything like that. In this scenario, we're just going to do it all in the code behind, kind of quick. And then what I'm going to do is put inside here some text to just say do an alt tab. I can also center this in the page. So we can say vertical alignment, center, horizontal alignment, center, and now it's there. So if we run this, I'll run it on the local machine. You'll see the button, but it's not going to do anything. Once it's done spinning up. Did it not spin up? Interesting. Oh, we should run it on 64-bit. Alright, now it's building. Cool, so we have a button, it's just on the screen. I can click it all day, but we want to wire this up to basically doing an alt tab. That requires us to basically add permissions to the app to say that it's allowed to do fake keyboard inputs and stuff like that. So to do that, we can go to the app's manifest. And in here, there's capabilities we can use, and then there's also like behind the scenes ones that we'll end up touching. But for example, we're going to need to start by saying that we need internet access, right? We need the ability to, we need any of this other stuff, probably not. Proximity, point of service, pictures, library, phone calls, nothing like that. And I guess that's really it. We just need that sort of hidden one. So I have another project that I had spun up. See if I can't grab it. Is it not in here? Guess not. So we can go look up that sort of special permission we need for UWP virtual key. So I'm going to keep this open, and we want UWP simulate key press. This is the stuff I was looking up before. So this is what we need. So we're basically going to be using this library here for Windows UI input preview injection. And then you can look at this sort of, where'd it go? I thought I just had it open. There's basically, we create a fake injector and then we just say like the name of the key that we're going to be using. So I think this is the one I was referencing before from Martin Zikmund. Yeah, because you can even do things like simulate gamepads, which I'll be using in another stream where we try to beat Dark Souls using like Discord chat and same sort of setup. But basically this is what we need, this res cap. And so you'll notice here in this capabilities section, there's internet client, which is the same as when we went to here and said capabilities and said internet client, but behind the scenes it's updating the XML. But there's a restricted one, this input injection broker, that we need. And you'll notice that that doesn't exist anywhere here. We have to actually open this up as an XML file, which I can do by going over here and saying open with and just choosing the XML editor. Yeah, we can close the other one. And now down here in capabilities, we need to add that input broker one. So we need the namespace, but for now, I'll paste this. And then we need to grab, like I said, the namespace here, which is how we tell it that we have this restricted one. So all the way at the top, we have like UAP and MP and stuff like that. We now need this rescap one. And I'll just get it lined up for my own sanity. So these are restricted capabilities. That's what rescap stands for, meaning that if you're going to try to publish this to like the actual like Windows Store or something like that, you're probably going to run into trouble because they don't want you simulating someone typing on a keyboard or clicking on things, because it can be used very easily in a malicious way to essentially hijack someone's computer just by using code and not letting them sort of get in the way of it. So now we have this, we can save it, and we're good to go. Referencing this blog post again, there's basically this injector type, and then they use this mouse info. But what I'm going to want to do is instead use the keyboard info down here, and instead of saying a letter and typing it out, we're going to want to grab the virtual keys for Alt and Tab. So I'm going to start with this, and we're going to go to the code behind where it generated this button click. So this is the code right here that's going to be called whenever we click that button. If I paste this and we get a new injected keyboard, we need to pull in the namespace for it for the ones that were referenced there. and then we want to skip this, and we need to basically say like we want to get virtual key dot alt. What is the one for alt? It's something else. It's like left. It's like left menu or something. Left. Yeah, left menu. This is the same as hitting that left alt. So what we're going to need to do is we can instead create two different versions of this. We'll say like alt info. If I can type alt info, we'll rename that. And then we'll also do tab info. I'll just copy all this stuff. Tab info. And this is going to be tab. Cool. So then we can pass in the injection of two different keys. So we can say alt and tab. Easy peasy. Now I need to actually get a reference to this input injector. So I can say input injector equals input injector dot try create. So if we don't have permission, this will throw an exception. But we should have permission, so that's fine. Okay, so let's do this. Let's run it. I'm going to keep my left hand off the keyboard and just click it, and we should be able to actually have that Alt-Tab menu show up. Boom. Alt-Tab is there. We can even see our pretty paint picture from before. Cool. So all we need to do now to basically tie the two things together is create a WebSocket connection between our API when we execute stuff from Alexa and our client app that will be listening, and then actually basically make the calls to say like, okay, we got the jump intent, send the jump command down to this app. This app is going to say, okay, we got the jump command sent to us, simulate a spacebar input. And then we'll combine that for all the different ones we have, and then we can basically go take that into Warzone and see what we can't do with it. So to do this WebSocket connection stuff, what I'm going to be using is SignalR, which is the official provider of basically WebSocket connection, among other things. But in general, SignalR provides WebSocket, long polling, basically everything real time is their sort of goal with that, to handle connection management. They use a concept called hubs, where you reference a hub and then the clients can connect to the hub, and then your API can also get a reference to the hub, and that's basically like you say like this hub, send this info down, and then when you're receiving it on the other end in the desktop app, you'll get your function calls hit. I don't know if SignalR is included by default, but essentially what we need to do is create a hub controller or a hub reference in here, and then start to execute it from that controller we created. So we can say SignalR. This is what we want. This isn't the client, right? ASP.NET Core, SignalR. Just check the docs to make sure I don't install the right stuff. Hey, thanks for the follow, Druid. Okay. Let's go to the getting started section here. So their getting started stuff is all around like creating like a little chat bot. It's a very good use case for SignalR. I've definitely used it in the past for that. And then what we need to do, does it have it already? I think it just has it. Let's see if we can't just create a hub. So separate from the controllers, I'm going to create a new folder called hubs, and then we're just going to call this the Warzone hub. Oh, sweet! It's actually already included. I didn't have to do anything else. All right, cool. That's what we get there. You can just create hubs, and then we can create endpoints on this that are actually executed and give them names and stuff. So when you look at a hub, you can see like in this case they have this send message call, which is what's called when you want to hit it from the other side. But we actually don't need this necessarily as much as we need to get the context of it and then basically do the same stuff. So now that we have that Warzone hub, we need to configure it just like we did for all this other stuff in the startup. So for example, I'm going to copy this service, use SignalR, and then we're going to also need to do that map hub to send to the Warzone hub. So looking at startup, right under the add MVC add controllers, we're going to add SignalR, and then under here in use endpoints, can we do it here? Endpoints.map hub. There we go. We'll say Warzone hub as the type, and then we'll just call this /Warzone. This is important because we're going to end up needing this URL route when we're connecting to it from that client app. We're basically going to tell our UWP app, our desktop app, that we should use the Warzone hub when we're connecting, and that way we can basically keep a reference to it on both sides. So now that these are set up and injected, we can get a reference to this and start adding these methods. But what we can also do is use dependency injection on our controller to get a reference to it as well. So I think it's called a hub context. So we can create a private read-only hub context, iHub context, of our Warzone hub. We'll call this Warzone hub. Now, one of my favorite keyboard shortcuts, control period, generate constructor. So now we can automatically get a reference to this Warzone hub, which means that we can start to execute commands. So for example, if we wanted to execute reloading, rather than just returning this response builder here, we can say Warzone hub.clients.all.send async. So we're going to be sending a message down. We're going to call the method reload. And then we can also basically pass stuff into it. In this case, we don't really need to send anything down other than the name. So once we send this reload, we can pass that down to the client that's listening to it, which means that we can actually like shortcut this whole thing on this switch case and just use the intent name and then return the response there. So instead of just using reload, we can just take the name and pass that in from the intent. And that's all we need to handle. So now in our UWP code, when we're listening to it, we can handle the request coming up. So this might be everything we need to basically be running it from the API endpoint. So I'm going to republish this, and then on the client side we need to actually connect to it. So let me close that. Let's see, SignalR ASP.NET Core client. This is what we want. So we're going to need to install this package in our UWP app. And you can even see here they're even using the window and doing it in a UWP example. But basically, you create that hub connection, you pass in the URL, so that's that route where we created Warzone as our route. And then we basically add these like, hey, whenever someone sends the receive message, we need to do this. So we can just do like, whenever we get the reload intent, reload, and go from there. So let's go get that set up. Let's go add that package to our UWP project, which we can do by going over here, going to references, manage Nougat packages, and I'm just going to paste what I had copied there for the name. So now we have our client package we can install. Actually, probably should have done it with a different version to match the version we're using on the server. I'm actually going to cancel that. We should match the same version that we've been using everywhere else. We're using 3.03 like when we were installing that JSON package, because our server is only running ASP.NET Core 3.0, not 3.1. So I'm going to install this version instead. Oh my, there's a lot of things it's going to add. Okay, we are installed. So now instead of having this button click basically do keyboard injection, instead what I want to do is have it start connecting to that hub. So I'm going to clear that stuff out. Actually, I'll just comment it because we're going to want to keep references to that. And I'm going to change the text of this instead of doing Alt-Tab to say connect to remote controller. Cool. I'm also going to give this a yeah, we're going to give this a name. That way we can change the text of it behind the scenes in the code behind once we are connected. Call it connect button. Sweet. Now I'm going to go back to the docs over here and basically get a reference to this. So we're going to have a hub connection. We need to keep a reference to that. I'm just going to side by side these. Oop. Hey, thanks for the follow between the bird. I'm going to be awful at pronouncing these names. Alright, so we've got a private hub connection. Let's pull in the namespace from the package we just added. And so now when we hit the connect, which is going to be over here, thanks. Yeah, super smart. We're going to want to initialize the connection. So we're going to go down here, create our connection, except instead of having this route, we're going to want to grab the route from our Warzone voice controller.azurewebsites.net. So we've got that, and then the hub name, we slide on over, is going to be that /Warzone. So that's, again, because in the startup we registered it here to map the hub. So now in our main page, we're mapping to the same hub on our actual server, and that's great. This is going to basically just keep us connected, but I'm not really sure I want to do that. So what we're going to want to do is change it when we're closed, right? When the connection actually ends, we're going to want to basically hit this inner function here, this delegate function. So what I want to do instead is change the connect button's text. How do I even do this, like inner content? Content equals you were disconnected. Click to reconnect. And then we can also add handlers for when it's connected. Connected on, let's see, we got all sorts of stuff we can do here. Where are these events? Reconnected, reconnecting. These might actually be the ones that are called when we connect too. So let's just do this on reconnected. This doesn't need to be async. Not sure why we're doing that. Then we can also func string task does not take, so we'll say message. Slap that. So now we can say the connect button dot content equals you are connected. Now what does this not like? Oh, we need to return a task. Return task.completed task for both of these. Cool. Now, similar to what they were showing us in the docs here as well, we need to be able to say that when we're connecting and before we actually start the connection, we need to handle these different messages that come in. So what we can do now is when we're connected and we're setting these up, we're going to register all of our handlers. Get this out of the way. Clear this, because this is where we're going to basically like put this code. Reformat my stuff. Let's say like when we get the reload intent, I think I can just do this, right? I don't even need a message. When we get the reload intent, we basically want to do this. And instead of doing left menu, we want to do R. And we'll change this from, oops, I'm going to rename this to R info. And we can get rid of that. Now we're registering that handler. We'll start with that one, and then we can abstract this so we have some cleaner methods for each of the other ones, just so we just have to pass in the key we need. But before we do that, now we want to await connection dot start async, which means we need to make this an async handler. Async voids are yucky, but when it's a click handler, it's the only way. Cool. So why don't we give this a shot and see if we can run it. And I'm going to just put a breakpoint in here so we know if we get the reload intent properly sent down to us. So once again, I'm just going to come over here. Let's get this on this side. Cool. I'm going to refresh this session. And so again, we can just one-shot into it. So we can say, tell Warzone controller to reload.
You are reloading.
Cool. So we got that response because we're not actually connected yet. So now if we start to connect, looks like something happened there. Let's try to do this one again now.
You are reloading.
Did it do anything? Did we get anything? Hard to say. Do we get any errors in here? What did I do wrong again? Oh, it should just be started. We didn't get any exceptions. Maybe we're just not actually hitting it properly. That's fine. Is it not the right name? Let's try doing this. We can say connection dot on reload intent. Oh, I think that's why. We're actually assuming we have a message, which is not the case. Alright, let's do this. We'll full screen this. So one of the interesting things about SignalR is that it's not just type safe to the name, it's also type safe to the parameters. So because we were in the dumb copy paste version of what we did there is had a reference where we were expecting a user to be sent down in the message, where that's not actually we're not sending anything down. We should just use the regular on. Now let's see if we can connect. And now over here, let's see if we can't get this to hit.
You are reloading.
There we go, we hit our breakpoint. So now our actual client app is receiving that we should be reloading. And even further, we're going to be actually stepping through and simulating pressing the R key, which means if you see right there, it literally just popped up the R, even though it's yelling at me because I'm editing while I'm debugging, which is awesome. Okay, so now what we need to do is just set up the other intents and the other handlers for it, and then we can just basically create these injectors and pass in a virtual key. So I'm going to create a private method in here. Private void hit key, and we're just going to pass in a virtual key. Virtual key. Come on, hands. Cool. Now instead of typing this one, we're just going to pass in the key version, and we'll rename this to something more appropriate like key info. Awesome. So now on reload intent, we just need to say hit key virtual key.r. And we can just pass in all the other things that we have too. So let me once again side by side this with our intents list here. So we've got reload intent, armor intent, sprint, shoot, ping, enemy ping, cut, shoot, jump, crouch, prone. Okay, now let me go replace all of these again. Oh, whoops. And I'm missing semicolons on each of them. Brilliant. Okay, so this one is armor intent, and the armor key is 4. For default anyway. Sprint. Oh, there is no 4, huh? How do I do numbers? Number 4. Cool. Sprint is left shift, because you can actually separate left from right shift. Let's see, what do we have after sprint? Shoot. This one actually needs to be a little bit different because it needs to be a mouse button, which we'll comment this out for now. But we're eventually going to want to have some mouse handlers in here too. That way we can actually simulate left click, which is the default shoot. But anyway, we'll get to that after we validate some of this other stuff. So we've got the shoot intent, we've got ping, which is again that left menu, which is the same as left alt. We've got enemy ping intent, which is just doing it twice. Ping. So I can just take this and do it 2 times. After enemy ping, we have cut shoot, which is C, I think. I'm like trying to remember. I've got like muscle memory now from playing the game. I can't like. I gotta think about it. Like space C. Okay. Okay. After cut shoot, we've got jump, which is our space bar. We've got crouch, which I think default is C. For me, it's left control. And then we've got prone, which for me is holding left control, which again we'll have to do some special stuff here. But I need some semicolons up in here. I'm gonna comment this out for now. So basically we've got everything covered other than shoot and prone intent. Now what I want to also do is keep this going as a log in the app, so we can kind of like keep it side by side and see everything that's going on. So what I'm going to do is on the main page, I'm also going to add a text block right below this, and we'll give it a name equals command log, and it has a text property, but we're basically going to keep that empty for now. And we're going to also vertical align center, and horizontal align center. Now we can also just put these in, actually that's probably fine. Okay, so now when we're getting commands, I want to also like print out that we're doing that command. So we can say command, what did I even just call it? My goodness. Command log. Say command log.text plus equals reloading. We'll even do this as a new line, using the \n escape. And at the top, we want to initialize this text to say command log. Sweet. Hello, Rolling Deaf Cradle. Thanks for the follow. Okay, so we're going to issue these in new lines for each one. So we've got /n putting on armor. We can do /n sprinting. We'll even put this in here for shooting, pinging enemy, cutting shoot, jumping. Oops, don't need the extra space there. Crouching, and then we'll even put the one in here for going prone. Cool. So let's do this. Let's run it now, and then we can actually, we're almost at the point of hopping into Warzone and giving it a shot. So let's run the local one. I don't think we need to issue any new updates to the server, so that's just about done. Oh no, the log is right inside it. Okay, we're connecting. We're connected. Let's go over to test. I'm gonna keep this window over here. I'm gonna keep it like super slim, actually. Just keep it like that. Okay. We're gonna say tell Warzone controller to reload.
You are reloading.
Now let's just do that a whole bunch of times. You can see it's even typing R in here the whole time. Do that again. So you see the text stacking up here on the right side, validating that we're doing it. Now let's do to shoot.
You are shooting.
You got the shooting pop up here. Now I've got all these devices around me. I've got one right here. I've got my little echo dot. I'm gonna wake it up and also try to hit it. So let's see what we can do. Alexa, tell Warzone controller to reload.
You are reloading.
We got it. You see the reloading pop up here, and we just heard it. So let me fix this up. We're going to put the connect button at the top. We're going to put the log underneath it and just let it keep scrolling. And then I think we should just hop in game and see if we can't get this to work and just start yelling at it. And then we'll work on basically getting it smoothed out, making it so we don't have to do this whole long one-word thing if we can. Try to figure out how we can make it better. If you have any other ideas for other commands or other things you want to see it do as we're starting to build it out, throw it in chat. We can talk through and figure out ways that we can make it even easier to use. But for now, let's go clean up this UI and make it look a bit better. So right now, everything is in a grid. And it means that in a grid in UWP, you can separate it by rows and columns and stuff like that, but because we didn't do that for this, they're all just centered on top of each other with like a grid of one row and one column, which means it's useless. So what we can do is set up column definitions, grid.row definitions and column definitions. We probably want row definitions, And what we can do here is define the rows by height. So for this first one, our first row, we can just make it like 100 pixels high. And then for the second row, we can make it take up the rest of the space by using the asterisk. So it's sort of saying like, if this one's 100, then calculate this as the rest. Now what I need to do is put this button in this row and this text in the second row, so that way it can sort of scroll and expand. So what I'm going to do is put this one in grid.row 0, so it's 0 indexed, and then this one is going to be in grid.row 1. So now if we hop back over here, we can even see it changing live. We have the connect remote controller all the way up here and the text logs here. It also means we probably don't need to vertically align center it. We can just put it right underneath. So now we have it running right here. So now if again I say, Alexa, tell Warzone controller to shoot.
You are shooting.
Let me get that shoot pop up. Sweet. Well, we got that through that actually surprisingly fast. Maybe I'm just talking too fast, but I think we should just hop in game and see if we can't get it to start working. And now let's just really hope that I don't get banned for using behind the scenes control inputs from Alexa. But let's get it started. I'm going to open up BattleNet. I'm going to swing this over to the left once it's done loading, so you don't have to see all my BattleNet stuff. And let's spin up the game here. Now be prepared for the loudest intro sound you possibly can hear if you're hearing desktop audio. Although I might have turned it down. You can turn it up a little bit so we can hear the in-game. Alright, I'm going to switch my window settings so that way we can actually watch the log happen on the right and we can play it on the left side too. So let's do this. Go to my options. Oh. Did it just crash on me? Maybe I already got banned. It just crashed on me. I might have got kicked out. Uh-oh. Come on. Please don't kick me out. Here, you know what we're gonna do? We're gonna stop running this for the time being, and then we'll get it spun up. Come on, Activision, please don't ban me. I'm just doing this for the memes. Okay, options, graphics. Why? It just keeps crashing on me whenever I go to that. Okay, let's try to get in game. We don't need to side window it. Can kind of see what happens next. I'm gonna go into a private like test match first. That way we don't have to worry about getting kicked for using illegal stuff online at least, and then we can try it out. Has anyone else seen this happen where it just kicks you out like that? Okay. We can go to practice modes, Battle Royale practice mode, play training. Alright, let's see how this goes. If I issue a command and it crashes, then we'll know what's going on. Alright. Let's get it spun up. For those of you who haven't seen the game, I'll show you basically what's going on. And how we can basically start to issue the commands. Then we'll Alt-Tab, we'll go run the app again, and then we'll sort of see it start. See if we can't get the commands issued while we're playing here. So in the Battle Royale version of Warzone, essentially what happens is you jump out of this plane over the map, and in this trial mode, there's basically a map and then there's a circle you have to get to. So the idea is that the last one standing within a circle is the winner. And so you or your team, depending on what version you're playing, your goal is just to not die. And there's a lot of other nuances to it too, but really that's the gist of it. So what I can do is, once it lets me actually drop, now I can hit space and drop. Me and all these NPC bad guys are falling. I can deploy my parachute like we talked about. I can cut my parachute. I can go run in and grab contracts and stuff. I can fall down all the way. And now I'm running around. So right, like now I can aim down my sights. I can shoot by clicking. I can crouch. I can go prone. I can reload. If I have armor that I found, I can do that. I can pick stuff up. Oh, that's one of the ones we need to do. Pick stuff up. So I can grab like gas masks and guns. I can, again, just aim down sight, hold the mouse button and shoot, stuff like that, right? So that's the gist of the game mechanically. Now there's other aspects to it, including like contracts and missions and everything else you do along the way to help get money, get new stuff, get your loadout, etc. But now, for example, I can pick up that armor plate, and now when I hit 4, I'm going to put on armor. So let's do this. I'm going to go prone so that these NPCs don't find me, and then we're going to go over here and kick this off again. So now, once this is running in the background, we can try to issue these different commands with Alexa and see if we can get to start going here. So we have this running. It's spun up. I'm connecting. We are connected, and it's crashing. It's kicking me out every time. Thanks, Suave, old man. Thanks for the follow. Dang, I wonder if it's gonna keep kicking me out every time we try to run this with the keylogger. I have a feeling that's just like it doesn't like me using that. Let me see. I'm gonna stop running it again, and instead of going into Warzone, we can go into a single player mode and see if that works. It's a shame. It'd be really cool if we could actually get it to happen in Warzone. I promise I'm not cheating. I'm not doing anything illegal or automated. I just want to yell at my Echo devices. Okay, let's try this. Let's go to campaign. I understand. And we'll just go into a mission here. Sure. And we'll do it on recruit just because it's going to be bad if we're trying to do it the hard way. Okay. So this is just the single player mode that lets us like actually go through these missions. I'll drop the desktop audio. So we can skip these cutscenes now and get into the game where we'll be able to do most of the same stuff. Except that we don't get to like put on armor or ping things. Those are really the ones that are missing. But we can still validate everything's working here by hitting like crouch and prone and stuff. So it's still the same thing. Like I can crouch, I can go prone, I can shoot and reload. So now let's see if we can't get our key stuff running, and hopefully it doesn't crash the game again. Okay, I'm gonna connect. No, every time it's just crashing. Why Warzone? Anyone got any ideas here for ways to sort of work around it? I'm gonna see if I can turn on like an offline mode or something this next time around. Maybe look at the logs to see what's happening. Or maybe I do need to like launch it in safe mode or something like that. We're so close. We have it running. We know it's doing all the things we want it to do. It just keeps kicking us out. Okay. Let's see if we can disconnect. And it's just crashing anyway because I'm still running this. One more time. If not, we can always try the same thing with a different game that is offline. Thanks. Thanks, Sploot. Blessed Poot 1. I'm gonna see if we can't get this to work. Running it in some sort of offline mode. And then... yeah, I tried to do it in practice mode, and the second I start running the client app, it just keeps kicking me out. And I was just trying to do it in campaign mode too, which in theory should be entirely offline. But what I'm going to try to do is see if I can just actually explicitly disconnect. If anyone knows how to do that, let me know. I've never actually tried to like disconnect. I don't even know if it lets you play if you don't have internet connection. Account. Streamer mode enabled. That way no one can see my real friends. False. Okay. Hi, Chris. Let's see. Anyone know if there's a way to basically... We're definitely going to disable that. And we'll even disable that. If there's a way to like disconnect or like go offline while you're playing. If not, I might have to try this with a different game that's entirely offline. But that's okay. We can always make some pivots here. Alright, see you, Chris. Thanks for stopping by. I'm not seeing anything. I don't even know if it's gonna let me connect if I'm offline. I can appear offline. Same options here. Nothing new. All right, we might not be able to do this if it's considering us as cheating, and that's the reason it's crashing. Let me see if there's any logs that are dropped, like if they actually put up any logs when they crash that I can look at. Call of Duty Modern Warfare crash logs. Let's see if it tells us where to go to. You can always just take a look at like our routes. Might be in temp. Nope. Might be in... I don't even know where this thing installs. Might be on my other drive. Do I have another drive? Let's see. Users. Got app data, local. Is there any Modern Warfare stuff? Blizzard, maybe? Blizzard Entertainment? Overwatch is in there. Oh, Battle.net. Logs? It's all just the actual Battle.net logs. I want the Activision ones from Modern Warfare. If anyone in the chat knows where like they write their stuff to, that'd be super helpful as we can actually go take a look at it. Thank you for the follow, Sta. Because I'd like to do it just to basically see that it actually worked all the way through, but I also don't want to get banned. That ain't it. Maybe it's roaming. No. Let's see. Modern Warfare, local data. No, not local data. Corrupt. Stop. You know what? I can look over here. I'm gonna look at my Battle.net settings. I'm just gonna keep these off stream just to see where my stuff is saving to. Oh, okay. I think I found it. Not sure why it installs just 32-bit. Call of Duty Modern Warfare. Data. No. Where are your logs? Alright, a little bit of a pain. Let's do this. I'm going to take a short break. I'm going to go find a different game that we can actually run this against. That way we don't actually get kicked out of Modern Warfare. So we can take like 5 minutes. I'm going to go find some other stuff to do. We can probably switch over to like Dark Souls or something like that. and start using some of those commands instead. But it's a shame. If anyone knows any other ways around this, let me know. Put it in chat, and I'll be right back. Okay. Hello, chat. We're back. So I was just checking some stuff, seeing what other games I also had and everything else. So it definitely looks like if I do this like more than 5 times, I'm gonna get straight up banned. I might need to reach out to some people I know at Activision, see if there's any way around it, because I feel like it would still just be hilarious to yell at my Alexa while trying to play Warzone, and obviously put myself in more of a disadvantage than any actual advantage. But for now, because it's using virtual keys behind the scenes, it's not a big fan, and their anti-cheat is basically just forcing a crash. So what I'm going to try to do instead is we'll pivot to a game that we can actually play offline. And so out of all of the games I have and that I enjoy the most, I'm thinking that I might want to do it using the original Dark Souls game, which very much a pivot from what we were doing before, and I'm definitely going to go update the stream now to let everyone know. But I think we can do the same sort of thing of trying to actually control our character in Dark Souls instead of Warzone using our Alexa device. So although all of our endpoints and URLs and everything else are called Warzone, I don't want to start from complete scratch here. So we'll try to get something working. I think in the end, as long as we can actually show using the Alexa as like a controller for any of these games, I think it'll still be really cool. But in any case, we know that it's at least working. So I'm gonna quit out of this stuff, and we'll leave BattleNet, and then we'll switch up some stuff. So for those of you who don't know, Dark Souls is an RPG game. It's commonly touted as basically the hardest game, and especially like the hardest series, like the hardest series of games ever made. It's really difficult combat wise and story wise, and like with that we need to make it even funnier by trying to control it using our Alexa. So I normally play with a controller. You can play with mouse and keyboard, so we can issue some of those same commands. But really all we need to do is we can change up our invocation name for the Alexa skill, call it like Dark Souls controller, and then we can launch the game in complete offline mode. That way we don't risk getting caught by any other anti-cheats or anything like that, and then hopefully that actually lets us run it, unless it's something behind the scenes that's actually crashing and it's not necessarily the anti-cheat itself that's catching us, because that would be a pain if other people are running that too. So before I even jump into that, what I'm going to do is try to just run Dark Souls and then run our controller at the same time, and that way we can know ahead of time before we really get all the way into it if we're going to run into issues with the virtual input. If we do, then we can always sort of pivot again to like a browser game or something like that. But if you guys have any games you'd recommend trying to do this with as well, put them in chat, and we can take a look, especially browser games if this Dark Souls one doesn't work. But let's get started on that. So like I said, I'm gonna go spin up Dark Souls, which I think I have installed. So I'm gonna go grab it from Steam, and of course we have a Steam update. I don't even know if I have Dark Souls installed on this box, if I'm being honest. I might have to do it just in Dark Souls 3, which is fine. Okay. Yeah, alright, we have Dark Souls 3, which is fine. It's all the same stuff. Get rid of this ad. So I'm going to spin up Dark Souls 3. We're going to, again, just see if we can run it in like a windowed mode, and then start to understand the controls that we have and how to make use of them. So we'll probably have to make some updates to the interaction model for the Warzone controller. One, to give it the new invocation name, and two, to actually like issue some other commands, because obviously like we're not reloading if we're playing with swords, and we're not like crouching in Dark Souls or anything like that. But we do have like sprint, we do have the ability to attack and stuff like that. So we're just going to take a look at what kind of things we can do using Alexa in the game control. But I'm first going to launch it. I'm going to switch to offline mode. That way we don't risk getting caught by anti-cheats or anything like that. And then we should be good to go to start trying it, just to make sure that if we are running our keylogger and controller behind the scenes, that we're not going to run into issues. So let me turn my desktop audio just a little bit so you guys can actually hear it. And I'm going to say new game.
Yes, indeed. It is called Lothric, where the transitory lands of the Lords of Cinder converge. In venturing north.
Okay. I was really tempted to let you guys watch the whole intro, but I can provide some context to what it is. So, like I said, Dark Souls is an RPG game. The general concept is that you're an undead. You can die and come back, and you're an unkindled as well, or rekindled. I forget what they're calling us in this game. But basically, your job is to find the other Lords of Cinder and basically either relight the flame or basically cast into darkness, which is sort of this like endless cycle of like the Age of Humans versus the Age of Gods. It's like this whole insane amount of lore that I could spend days talking to you about. I love this game. It's like defined my adulthood, my young adulthood. But anyway, we'll call ourselves Suave Streams, and we'll choose a class here. I gotta like remember these. But we can start as a knight, and then we'll choose the burial gift of black fire bombs. I'll just go with the defaults for now, and we'll get started. So we're going to come in. We're basically like awakening from the dead here, and then we can start to move around. I haven't played this game with mouse and keyboard, but I'm going to try it in this case. I played the original Dark Souls in mouse and keyboard, which is not meant to be played that way. Okay, so we can move around. I can move the mouse side to side to basically pan the camera. WASD, forward, right, left, S to go backwards, and it actually moves my character. Control is parry, left click is attack, right click is holding your shield. Trying to remember what roll is. Let's see. F is two-hand, so now I can two-hand my weapon. Let's see what else we got here. What is V? G is emotes. R is use item, so that's good. We already have the key bindings for that. And yeah, so we should be able to focus mostly on like attack and movement and using our items basically. So let's do this. We're going to change our options to offline mode. And I'm also going to change this from full screen to windowed. That way we can run our other stuff behind the scenes. So yes, keep that setting. And can I make this bigger? How about this? A little better. I want to get it to like a resolution where I can still like see everything. There we go. Now we can still run it on our console on the right side. Cool. Quality settings high. Matchmaking off. Here we go. We want to play offline. Cool. All right. So we can move around and stuff. Let's see if we can launch our game controller without being kicked off the game. Alright, so we're gonna snap this over here and shrink it a bit. Okay. Now, even before we go and actually update all these commands and stuff, let's see if we can get some of these commands to execute. We can say, oh, let me unmute it. Alexa, tell Warzone controller to reload.
You are reloading.
Did it do it? I didn't get anything in the oh, I'm not connected. Duh. Okay, now we're going to connect and now we can do it again. Alexa, tell Warzone controller to reload.
You are reloading.
Tried to do it. It didn't actually execute anything. Does shift do anything? Control? Okay. Alexa, tell Warzone controller to crouch.
You are crouching.
It's not actually executing anything in game, which is interesting. Oh, Frank Kruger, thanks for the raid, man. Appreciate it. For everyone else who's joining, basically what we're trying to do and what we were originally trying to do is turn our Alexa controller into a controller for Warzone. Now, basically what the setup is on my beautiful architecture diagram is that Alexa sends information to our skill, which is an ASP.NET Core API running in Azure. Our skill then talks to a UWP app over SignalR WebSockets, and that app is executing a bunch of commands against keyboards and stuff like that. So it's all running in .NET. We're running it behind the scenes. Give you a breakdown here. We have our API, which has an Alexa controller. Basically what we do is we go over each of the intents. If it wants to just open the file, what are we doing here? Come on, Visual Studio. Can't open anything. Oh, we're just running real slow, that's all. Or it just crashed. Hold on. So we have our controller, which for some reason isn't opening. Maybe we just need to stop debugging. Nope. Oh, it might just be that we're stuck in the control. Hold on. It's interesting. Either way, we're going to need to split up. But basically, our controller takes each of the intents that we've defined and then runs them and then makes a WebSocket connection to us. And then our UWP app says, hey, we got this intent. Let's go and actually like execute these keyboard commands. So we tried doing that in Warzone. Everything is set up right now for Warzone. And basically what happened is every time I was spinning up Warzone and running my key client, it basically just kept kicking itself out and it was crashing the app. I'm pretty sure it's their anti-cheat checking for our virtual input stuff that's running, which means that I'll probably get banned, but that's fine. So what we're doing now is trying a game that's in offline mode. This is Dark Souls 3, and we're going to try to execute the same stuff. So what I can do is when I run the client app, we'll again just sort of pivot it here. I have an echo in front of me, but we can also do this from any of our Alexa devices we have behind us or from the simulator. But essentially, I can say things like, Alexa, tell Warzone controller to crouch.
You are crouching.
And when we're connected, which again I've forgotten to do, we'll start to see them actually execute in this little command log. So now if I say, Alexa, tell Warzone controller to reload. Alexa, tell Warzone controller to reload.
You are reloading.
So we get that command that basically pops up, and that should be basically executing the virtual R in there. But now we're just sort of running into a problem where R normally should actually use my item in Dark Souls, but it doesn't seem to be doing that. And I'm wondering if we can do a better job at, instead of simulating the keyboard, to simulate using the Xbox controller, which I have over here, and we can switch over, and you can do virtual inputs with those as well. But now that I'm in game, I'm going to try one more time. Alexa, tell Warzone controller to reload.
You are reloading.
Yeah, so we got the command to pop up, but nothing's actually happening here. So that's fine. What we're going to do is we're going to save and quit the game. We might need to have it running before we get in game 2, but at least we know that the game didn't crash and we didn't get kicked out or banned like we were in Warzone. So now let's go actually update this stuff to handle all of our actual inputs here for Dark Souls instead. So I'm going to head over here to the Alexa Developer Console, and we can rename our skill and change all that stuff, or we can build it from scratch and just use the same URL. But for now, let's just go change the invocation name to Dark Souls Controller from Warzone Controller. So we'll say Dark Souls, and again, we'll save that. Now, instead of the reload intent, we should call this the use item intent. And we can add some other stuff like use item. I'll keep the other utterances and stuff in there because it's not really a big deal. Let's see, we have the ability to attack, which is the same as shoot. I'm going to change this to the attack intent. Which we already have the phrase there for, so that's totally fine. Save those changes. And then, let's see, what else do we want to do? We want to be able to hold our shield or use our right click as well. So I'm going to go ahead and use a new intent that's called shield intent. Assuming that we're actually playing with the shield, but we can say like use shield, let's say right attack in case we have another weapon on that side, just say shield or right hand. I think it's technically left hand, but that's fine, we'll just remove that one. Alright, let's save and build this. Now, because we changed the names of these intents and we added these new utterances, while this is building, we need to go update our endpoint to handle those different intents as well. So we can head over to our controller, which is still not opening. I think I might just need to restart Visual Studio, so let's do that. Visual Studio, get back into Warzone controller. Cool, so we have on our client side we're going to need to update these, and then also in that controller itself. So now let's see if we can open this thing. Come on. What are we doing here? I can type. I can click on things. Can I open other things? You can open that file. I just can't open my controller for some reason. Oh, it's opening it in an... I'm an idiot. Alright, cool. It was just opening it in like a different window. Okay. So let's side by side these, and we can re-reference the ones that we had here. So instead of reload intent, we have use item, and we'll change the output speech that we have from you are reloading to you are using an item. We have, instead of shoot intent, we have attack, and we can say you are attacking. What else did we change here? We have the use right hand, right? So like shield intent. I'm just going to copy this one. Say you are using your shield. field intent. So what's happening here is whenever we get this endpoint, we're in one of these intents that we just hit, and we're going to send that intent down through our SignalR hub. Our SignalR hub is also connected on the client side from our UWP app when we click that Start Connecting button task and handle a click event. So then we start connecting, and basically we're just sending down the exact intent name every time. We don't need to send any parameters. We definitely can, but we can actually just really simplify with just command route through the API down to the hub, down to the client. The client just executes the code there. So what we need to do now is in the code behind where we're handling all these different intents, we also need to switch these up to like attack intent. Wait a minute. Is this why it wasn't working? Come on. I had that commented out the whole time. That might have been why it wasn't working. Attack. Oh wait, no, this is not the right one. That was for reload. Reload was there. We still need to switch this to left click, which we'll get to. This is use item. We'll say using item, and that's still going to be R. And then the rest of these don't really matter. So now let's actually set up the mouse handlers as well. So you can create the same input injector, and you can do things with gamepad mode and mouse mode. So we'll just create a private void left click. We'll say input injector equals input injector dot try create, and then we can say var mouse info equals new injected mouse info dot, let's see, is it mouse data, mouse options, values based on the mouse options flag. Mouse options equals mouse options dot left down is probably what we're going to want. And we can say input injector dot inject mouse input, and then we can pass in the new array, because it's not actually using R, so we can say mouse info. Right, so then we're going to want to do a right click one as well. Right click. I'm going to say right down. And let's see, I feel like there was something else we were going to do. Oh, parry. We're going to want to add a parry intent. So let's do that. We'll just say parry intent. Actually, that's just the control, so we don't even need to create a new one. We can update the crouch one. So instead of crouch intent, we're going to use the parry intent. Again, I'll keep those there just in case we do end up using this for Warzone or some other first-person shooter. But for now, let's say parry, do a parry, and then we'll save and build that too. So this is all good. We need to now handle the parry intent in our controller again, just like we did with the other new adjustments. So we'll go to Alexa controller, and we'll change crouch to parry, and say you are parrying. Awesome. So now, again, on the client side, we should just change our crouch intent to parry intent, and we'll even just change the output here from crouching to parrying. Cool. So this is still building. It's just finished building. So we need to republish our client, which again I'll just right-click publish. The same Warzone controller. We're not going to change the hub names or anything like that. Let's just stick with calling the Warzone stuff. I still really want to figure out a way to do it. I'm pretty bummed that we didn't get to do it, even just in practice mode or the campaign mode, because I feel like it would just be hilarious to do it that way. But we'll get it working with Dark Souls, and we can figure out what's going on here. So first thing I'm going to try is just getting some of these commands to actually execute when the game's running, and then if that doesn't work, we can try switching to controller input, which is also, I'm more familiar playing the game with an Xbox One controller anyway, so we'll switch over to that if we can't get this to work. And then depending on time, and we've got like 90 minutes left for this stream, I'll always be picking it up back next Wednesday at 6 p.m. Eastern, but either way I'm going to try to do the controller stuff anyways. I think it'd be hilarious. So okay, we've got our Warzone controller published. Let's make sure that we can hit it from the test console here in Alexa. So if I say tell Dark Souls controller to parry,
You are parrying.
There we go. So that's our expected response. That's good. Now let's try to run our client again and see if we can get it running. And then I'm going to try just booting up Dark Souls while it's running already, seeing if that helps too. But let's connect. I'm again just going to kind of snap this and keep it over on the side. Now I'm going to type the same thing in here just to make sure it pops up on the log. So using the simulator, I'll say tell Dark Souls to parry.
You are parrying.
And we've got the parry there. Cool. So let's try this. Let's spin up Dark Souls again, Dark Souls 3. And we'll hop into that same game, and we'll see if we can start getting these commands executed, and then we're going to try to play a little bit using it. And then even if that succeeds, we can start to add more commands. We can start to use like motion controls using it, telling us to go forward, backwards, stuff like that. Oh, I'm an idiot. We should be using roll. It's like the most classic thing you do in Dark Souls is just roll away from all the bad guys. But I don't remember what that command is on the keyboard. So, okay, we're going to log in. We hit continue. Now I'm going to try to use my device that's right in front of me, see if we can't get it to work. Alexa, tell Dark Souls controller to parry.
You are attacking.
Well, that's just not true. That was me clicking, by the way. Don't get excited. Let's see if we're getting into the right stuff here. So attack, we want to be able to use that left click. So let's do this. We'll say left click. And then for shield intent, where did that go? Did we even account for that? We did not yet, and that's fine. We're going to have to respin this up. Let's try to get parry to work, or use item. Alexa, tell Dark Souls controller to use item.
You are using an item.
No, we're not. Alexa, tell Dark Souls controller to parry.
You are attacking.
Alright, let's figure out why this isn't working. Check out key bindings. Left alt is walk, WSD space space. Oh, space is roll. Okay. Alexa, tell Dark Souls controller to jump.
You are jumping.
Why aren't we jumping? We know it's working. We're getting the logs output here. We are hitting the virtual keys. I wonder if Dark Souls is doing something to block it, which we can try to find out. Let's see if there's anything in here that will tell us. Open menu. These are just bindings. Might have to do some research here. Advanced settings. That's just shadow settings. Alright, let's do this. Let's go look up what we can. Oops, not paint. That's hilarious. Let's see. Dark Souls 3, use virtual input. Uh-oh. Oh, that's just info lag stuff. Don't care about that. Anyone have any ideas for why we're not actually able to get the controller input to work? One thing we can start to do is just try to switch it to using the gamepad and simulating that. Theme streaming controller not working. This feels like what we're actually trying to do. I haven't tried Seam Link because this uses like virtual inputs and stuff when it's running behind the scenes. Raw input, even using a Bluetooth Xbox controller won't work. Uh-oh. Bluetooth didn't work just fine for me. Definitely can't get my stream controller working Wi-Fi though. Did virtual here work for you? Seemed to work fine on the Steam Link, but not in-home streaming. Okay, I wonder if there's a different way that we should be simulating the input here rather than using the controller. But let's do this. I'm going to get my controller working, and then we're going to try to keep using the virtual key injection, but we can issue some control. I gotta use a different mic. It keeps dropping my mic once I start connecting. Okay, anyway, we'll just use this mic for now, not this one. So we were gonna see if we couldn't simulate the keyboard control instead, but also I just think that there seems to be some behaviors with Dark Souls in particular that like doesn't allow it to do remote connections. Just re-looking at this sort of forum post here of people trying to use like the Steam controller, which is basically acting in the same way we do, where it's not working for them, and it seems like Dark Souls just does some like blocking of it. So we might need to see if there's a different way that we can basically simulate doing the keyboard controls without using the input injector, or even if there's a way to basically like route it through the same thing. So let's see here. UWP, simulate key press without the injector. I want to do this without input injector. I know we're probably going to start stepping on some some funky behaviors here, because most people are not trying to do simulated keyboards with the right intentions in mind. Otherwise, we can try to do a browser game. I had someone recommend one to me. Hold on. Someone just DM'd me suggesting a game. We see. Crunker.io. Let's take a look at that. This is interesting. Okay. Let's just host a game, maybe? I've never played this game before. We can give this a shot using our controls too, assuming that it does like virtual key stuff. Let's do this. I don't even know if this is free for all. Start server. This looks like it's like Minecraft, but like first-person shooters, which seems pretty cool. I've never heard about this before. Are we started? Share the link. What if I don't want to? I'm not sharing this with y'all. We can in a sec though. Okay. Click to play. Alright, we've got attack. We've got move forward, backward, strafe. Shift is like our crouch. Oops, sticky keys, that's hilarious. Space to jump. So let's get our controller running and see if we can do it this way, because this probably isn't going to care as much as a, A-series game that's going on in the background. So we'll again just sort of shift this over here. We'll keep calling it our Dark Souls controller for now, but maybe this will become our Crunker controller.
I'm on it.
What? Okay. Sorry, I think my HomePod just started talking to me. Classic. Okay. Let's connect to the remote controller. Now, it's still called Dark Souls controller. Oh no, there are random people in here. Hello, Goldie. Okay, let's try this. Alexa, tell Dark Souls controller to jump. Oh, we did it! We can actually play a game with this thing. Alexa, tell Dark Souls controller to attack.
You are attacking.
What? Okay, this is actually sick. I'm just endlessly attacking because it's just as if I'm holding down the mouse click. If I click in real life, it'll stop doing it. Does right click do anything? No. Jump, jump. Okay, I'm gonna start moving. I don't even know how this works. Whoa. Secret, okay. This is a really cool game. Thanks for sharing this, by the way. Okay, so we're gonna play a little bit of this. Break the floor when the countdown ends, and defend the base if you're a human, or invade if you're a zombie. Don't forget to like the map to support the game for future updates. Good luck. Okay. How do I break the floor? Oh, waiting for other players, that's why. Alexa, tell Dark Souls controller to jump.
You are jumping.
Oh, I'm like stuck in here now. Alexa, tell Dark Souls controller to attack.
You are attacking.
No, I'm not. Oh, it's not working now. Alexa, tell Dark Souls controller to attack.
You are attacking.
Alexa, tell Dark Souls controller to jump.
You
There
are
we go.
jumping.
Alexa, tell Dark Souls controller to attack.
You are attacking.
It's interesting. It seems to like kind of work every now and then, but then like doesn't work on some commands. Even though we're seeing it come up in the logs over here on the right side. Yeah, I think what would be interesting is to take that same sort of concept, this controller concept, put it on all these other assistants, and then maybe we can even get like the skill published, so that way when you guys are at home and we're on this live stream, you can actually just start executing things and making my guy do stuff too. I'm not sure how the testing procedure for that is going to go on the Amazon side. Like, it might be fine just because we provide responses to each request, which is like the main sort of safe thing. But we can try to get it to start to do other things as well, and let everyone else try to play this, and we can all from our homes now actually like control this one person. And then I think what I'd like to do is take this controller and put it in other conversational spaces too. So we have it as let me mute it. As an Alexa skill, we can turn it into a Google action, we can turn it into a Bixby capsule, and then whenever we're playing on these live streams or building other things, we can have everyone actually use it on whatever device they want, controlling whatever character we're using. Alternatively, we could also do it like create an actual Twitch bot that listens to your commands. So whenever one of you guys types W, it'll move forward. Or whenever someone types to attack, it'll attack, and then all of us can just control it from the chat. I think that'd be pretty cool. But I might actually end it here. I gotta go figure out what's going on with my machine and why it keeps killing my mic and stuff and the game controller stuff. But I'm also gonna do some more research on the Warzone things, see if there is a way to get it to work, either using a different virtual type of input. Maybe instead of using input injector, we can actually basically register it as a device and do it that way, which will be a fun sort of thing to explore. Because if we do that, and it's not technically virtual, it's as if we were actually using hardware, but we can simulate the hardware. And then we can probably also get that to work in Dark Souls too. So I think that's going to be a pretty important thing to capture for us to keep doing these sort of like real-time, keep in sync conversational apps, and especially when we start to let everyone else get involved. Yeah, I'm going to end a little early today. Join me on Wednesday at 6 p.m. Eastern. I'm going to be continuing to build on this stuff. I'll come in with some research on the virtual hardware controllers and some other games, and also think of some other games we might want to try using these controllers for, and then we can see if we can't go through the publishing process, and I'll be able to show you guys what it's like to actually publish a skill to the skill store, how we can then create like routines and shortcuts for it. That way, instead of having to say like Alexa, tell Dark Souls controller to attack, I can just say attack, and it'll actually just run through everything, which would be really cool. But that's it. Thanks for joining the Suave stream, everyone. Sorry for the hardware issues we had earlier. But yeah, have a good one, and I'll see you on Wednesday.